Hello class, today we're going to cover how to conduct a hypothesis test to compare two means. To do that, we will be looking in section 9.2 at number 2. Listed below are time intervals in minutes between eruptions of geyser. Assume that the recent times are within the past few years, the past times are from around 20 years ago, and that the two samples are independent, simple random samples selected from normally distributed populations. Do not assume that the population standard deviations are equal. Does it appear that the mean time interval has changed? Is the conclusion affected by whether the significance level is 0.05 or 0.01? Let mu sub 1 be the recent times and mu sub 2 be the past times. What are the null and alternative hypotheses? Here are your numbers. Now let's go ahead and write down the hypotheses. Now for these hypotheses, we're going to have the null hypothesis, which is at h naught or h sub 0, and those always have equal signs. So we're going to say the two means are equal to each other. The alternative is that they're different, so the two means would be not equal to each other. And remember, mean would be mu for these. Now that we have the hypothesis, let's move on to the test statistic. To calculate the test statistic, we're going to need a formula as usual. The formula for this one, since we do not know what sigma is T equals, in parentheses, x sub 1 bar minus x sub 2 bar, close parentheses, minus, then in parentheses, mu sub 1 minus mu sub 2, all over, make a big square root, s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. Now, to use this, we're going to need to find x sub 1 bar, x sub 2 bar, and all these values. You can use your calculator to get these values. When I plug it in, I get x sub 1 bar is 78.82, s sub 1 is 13.97, n sub 1 is 17. X sub 2 bar is equal to 89.17. S sub 2 is equal to 9.25. And N sub 2 is equal to 12. Now that we know our values, let's plug them in. And remember, to get these, they weren't directly given to us. We had to use the calculator. So on this new page, when we plug these in, we get T equals 78.82 minus 89.17 minus 0. We know the two mu's are the same, so when we subtract them, or at least we're assuming the two mu's are the same, so when we subtract them, we get 0. That's all over the square root of 13.97 squared divided by 17 plus 9.25 squared divided by 12. When you plug this in the calculator, make sure you put the parentheses in the right area. We will get approximately negative 2.40. Now that we have our test statistic, we can find our p-value. Now remember, when using t-tables, we don't get exact p-values. We find an interval for these p-values. To do that, we need to first know what is our degree of freedom. The degree of freedom is your sample size minus 1, or n minus 1, which will give us 12 minus 1, which is 11. Make sure for your n you use the smaller of the two sample sizes. Now that we have our degrees of freedom, we can look in the t-table in that 11 degrees of freedom row, and we find out that our value is somewhere between, you could say, between 0.1 or 0.01 and 0.025, or you can double it right away and get between 0.02 and 0.05. Now that we have our p-value, let's move on to our conclusion. Now remember, we're going to have two different conclusions here. We're going to have a conclusion when alpha is equal to 0.05. Let's go ahead and do that one first. And although we don't know exactly what the p-value is, we know it's somewhere between 0.02 and 0.05. So the p-value is less than 0.05, which is alpha. Forgive my terribly drawn alpha there. That was meant to be an alpha. Since p-value is less than alpha, we will reject H9. Next, let's do a conclusion with alpha equal to 0.01. Well, p-value being between 0.02 and 0.05 is obviously greater than 0.01, which is equal to alpha this time. So since p-value is greater than alpha, we will fail to reject when alpha is 0.01. If you have any questions about how we read the table or got these numbers or plugged them in, please either message me or post in the class discussion board on Blackboard.